Welcome learners in today's lesson, and today we're going to look at programming languages. We shall start by defining programming languages, and programming languages basically are what you call environments or languages that enable programmers to come up with computer programs. And we say that in the process of coming up with computer programs, you guide the hardware, you command the hardware to perform a given task. So the language you're using to communicate your formula, your steps to the hardware is what we call programming languages. And there are 5 classes of programming languages. Number 1 is known as machine programming language. We can call it computer programming language. Another name for machine language, you can also call it first generation language. The second one is low level language. We can call it assembly language or second generation language. The third one is not high level language, or you can call it a third generation language. Then number 4 is not fourth generation language, or you can also call it fourth generation language, 4GLS. Then the last one is fifth generation language. We shall start by looking at machine programming language. And basically machine programming language, a program is written in form of zeros and ones, or binary language, which is basically a language that a computer can understand. The program I'm writing will be in form of zeros and ones, and these are in form of lines. So this is line number 1, this is line number 2, and all the lines are written in zeros and ones. So this language is what we call binary language, which is basically a language that a computer understands, or computer language. So a program written in machine language doesn't require translation, because the hardware devices of a computer will understand and be able to execute these instructions. But if we give a human being such a program to go through, it will take a longer period of time to understand, so it's not readable and easy to understand. But for the hardware, it can understand easily, but for a human being, you will find a challenge in understanding the importance, the functions of each and every line. Now, machine language programs depend on the architecture of a given computer. The architecture is in terms of a microprocessor. If I develop a program to add 2 numbers in machine language using one microprocessor or one architecture, like let's say Intel, then I transfer the same program to another machine with a different microprocessor or architecture like Celeron or AMD, that program will not be executed the same way, it will not work the same way until I modify it. That's one demerit about machine language programs. Then you can go to low-level language programs. Low-level language programs, a program is written using what you call human natural language, or the human vocabularies, to represent the operand part of a program, and using mnemonics to represent the operational part of a program. So a program has the operand and the operational part. The operand part of a program basically is in form of instructions or lines that will guide the hardware where to get data and where to store those data items. And the operational part of a program will guide the hardware on what to do with the data items. For example, if I say enter A, line 1, then I say enter B, and then I say add A to B, then I say print sum. This is an example of a program. This program has line 1, 2, 3, 4. Now this line 1 is enabling the hardware to acquire the value of the first number, which is A. This line 2 is enabling the hardware to acquire the value of the second number, which is B. This line number 3 is guiding the hardware to increase the value of A and B. This line number 4 will command the hardware to display the value of what you call the sum. So basically line 1, line 2, and line 4, they are on the operand part of our program, known as operand part. Then line number 3 is what we call operational part of our program. It will guide the hardware on what to do with the 2 numbers, number 1 and number 2, add, divide, compare, etc. So we are saying in low level, when you are coming up with the operand part of our program, we use what we call human readable form, human readable vocabularies. But when you are coming up with the operational part of our program, use what you call mnemonics. And mnemonics basically a keyword that has a particular or predefined meaning and function. For example, if you want to add, I use add. which means addition operation. If you want to divide numbers, say div. So div is a mnemonic for division operation. If you want to multiply, say mult for multiplication operation. If let's say want to subtract, say sub, calculating the difference. If you want to, let's say print something, I say print. I can say load. These are examples of mnemonics. So any program written in low level must be translated, because the computer always understands what is written in zeros and ones. So the program written in low level must be converted to zeros and ones. So low level language programs are converted using a special program known as assembler. So assembler is a program that converts low level language program into machine language so that the computer can understand and execute. Then you can move to high level language programs. So high level language is basically an environment that allows a user to program a hardware by using a language that is close to human natural language. If I form a program in high level, then I give you as a user a human being to go through, you can somehow understand, because the language I'm going to use is close to human natural language. For example, this is an example of a program written in high level. So if I give you a program to, let's say, go through this, you can understand because the language I've used is close to human natural language, and the vocabularies you can somehow understand them. So the lines are organized in an ordered manner from line 1 moving downwards. Each line, we call it an instruction, or we can call it a step, or we can call it a procedure, guiding a hardware to perform a given task. So basically, high-level language programs must be translated, and it uses two translators, namely one known as compiler, the another known as interpreter. So a compiler basically is a program that converts high-level language instructions into machine language all at once. For example, in this program, I have line 1, line 2, line 3, and line 4. If these program instructions are in high level, then I'm using a compiler. It will convert all the lines into machine program, zeros and ones. If I'm using an interpreter, it will convert line by line, one line at a time. That's the difference, line by line. So any program written in high level language, in a language that a human being can somehow understand, is known as what you call, is known as source code. Source code. So this is an example of source code. Once you translate into what you call zeros and ones, is known as object code. Object code. So object code is a translated instruction which is in zeros and ones that a computer can understand. We can move to fourth generation languages. Basically, these are languages that enable programmers to create online applications, and these are programs that run on the internet via web browsers. And a web browser is basically a program that displays anything on the internet, any resource on the internet. Each can be in form of hypermedia, meaning a combination of text, video, voice, and images. So the work of web browsers is basically to display. Now, internet refers to the physical connection of computers. If computers are connected all over the world, we form what we call internet. So for you to access anything on the internet, you have what we call the www. The World Wide Web is a service, is a program that runs on the internet to give users what we call universal access to resources. You're giving users universal access to resources. So basically, we are saying here that if I want to come up with an application that can run on the internet, enabling a given user to solve a given problem, I need to use what we call fourth generation languages. For example, we have the e-learning system of KIPS College. These systems allow you to access course materials, attend a class, ask a question, sit for an exam remotely on a different location. So it means there are two components involved. One is what we call a database, another is what we call an interface. So a database is basically an organized storage of data in form of resources stored in a central machine somewhere, and the machine that stores these resources is known as what we call a server. Then an interface is basically a point of interaction. That application that is enabling a user to interact, what you are using to log in, provide a username and password, then you log in. Once you log in, you can watch a video. That interface you're using is what you call point of interaction. Then the video you're watching, the audio you're listening to, is located on a different machine somewhere. So this machine storing that video you are watching, that audio, is known as a server. The device in form of mobile phone or a machine you are using to access this video, it means we call it a workstation. So the two must be connected. That's the work of the internet. Now to access any resource on that, you have to have what you call the www. So whoever comes up with a fourth generation languages has to be in a form whereby you think of a database and you think of an interface. Then the two must communicate, so they must be interconnected. Now the major functions of these programming languages is basically to allow users to perform some computations on data stored on a central point. You can, let's say, have an account in Equity Bank, but you can make a deposit at any location, then your account balance will increase by that amount. So if you had a balance of 10,000, then you make a deposit of 5,000, your account will increase to what you call 15,000. That's performing computations on data stored on a central point. Another one is basically allowing web content to have what you call dynamic content. The content you're accessing today is not the content you're going to access later. For example, if I set up a company and my companies provide news using the internet, allowing users, customers to access news at a cheaper cost using the internet, it means today's news will be different from yesterday's news. It will be different from tomorrow's news. So those web content keeps on changing by what you call fourth generation languages. Then lastly, we have what you call fifth generation languages. Basically, these are programming languages that are still in a state of development. They are still being developed, but some are being applied. And those ones that are being applied basically are being applied in a field known as artificial intelligence. Artificial intelligence is a branch of computer science that is concerned with creating devices that behave like a human being. A device that can imitate the human behavior. For example, we can have what you call a robot. A robot is a device that has physical components and it must be programmed. So it will be programmed using what you call fifth generation languages. So this robot can perform tasks which are dangerous to human life. Another example can be, let's say, in form of expert systems. Basically, this is an expert system that allows you. So I was saying that expert system, basically they are systems that fall under artificial intelligence, and are systems that enable we as users to interact with them, and they enable us solve our problems. For example, you can have a patient suffering in a given area in form of, let's say, spinal cord, in terms of head problems, etc. So you can have doctors who can handle those particular problems. So if a doctor who has a specialist in, let's say, spinal cord problems, such a person is a very important person in the society, is a very valuable individual. If we lose that particular person, if he or she dies, it means that's a loss. So what we can do, we can acquire knowledge that he uses to treat patients. Then we enter that knowledge, we harness that knowledge, we enter into a computer program by a system and allow users to interact with our patients to work with that particular system. What you do, you just enter the symptoms to a given system, then the system is able to diagnose and come up with some medication. We call it expert systems. They are systems that are able to acquire knowledge from human beings, store in form of an organized manner in form of a database, and allow people who have problems to interact with them, and they are able to solve those particular problems. So basically that marks the end of our lesson today, and today we are looking at computer programming languages, and we say that programming languages are basically environments, basically languages that assist we as programmers to be able to come up with computer programs. The same way, if you have a person, you have a friend, let's say from Germany, for you to communicate with that friend, he or she understands only German, and you understand English. You meet another friend from, let's say, Congo, or from, let's say, France, and that particular individual understands French. For you to communicate with that person, you need to understand French. So what you can do, we require environments, because I say we have to be able to command a hardware. So programming languages are able to allow us to be able to come up with computer programs. Thank you.